Oh, cool. I'm glad you're here because I've been wanting to show you how I created these stylized bushes in Unity using Blender and Shader Graph. In this video, we're going to start by creating a bush which has 600 triangles using Blender's particle system. We're then going to hop over into Unity and start building our custom shrubbery shader. This shader is going to allow us to configure all sorts of cool things, such as setting the color using a gradient, and we'll also be able to change the overall look just by swapping out the leaf texture. Not only that, but we'll be able to overlay a second details texture, and we'll be able to control its color too. And to take it a step further, we'll be able to overlay yet a third emissive texture, which will be able to glow in the dark. And in order to achieve a more stylized look, we'll want to be able to control the direction of the normals. Next, our shrubs will be pretty boring if they don't move. So we'll start by adding a cascading wind effect that will realistically collide with the bushes on the right and pass through them. We'll be able to control the wind speed frequency and the bend strength. But most importantly, we'll be able to control how far down the leaves can be affected by the wind. Alright, so if you're interested in seeing how I created this stylized shrub shader, then stick around! So start by drawing some white leaves on a transparent background. I've enabled a black background here just so that it shows clearly on the video. You have a couple of options. You could draw some loose leaves like these, or some dense leaves like these, and later on you'll see the effect these produce. When you're done, let's move over to Blender to create the bush. Start by creating a square plane. Create an edge between these two corners, then UV unwrap it to fill the entire UV space. It's important that this be a square, and that the square fill the UV space. The reason we want this to be a square is because we're going to create a contract in Unity, so that we can swap out the leaves at any time with any other leaf texture, and the leaves won't stretch. But there's another reason. The reason is that by the end of this, our shader is going to allow us to assign a main texture, a details texture, and an emissive texture. And we want to be able to swap out those textures at any time with any other ones, and know that it's going to neatly map to our UV and not stretch. For instance, watch how I'm able to swap out the leaf texture of this bush and change its appearance. So just make sure that your plane is a square and that it fills the UV space. Then create a material on the plane and map our leaf texture to it. The last thing is to go into edit mode and rotate it so that the normals face the positive Y direction. The next step is to create the base mesh or the overall shape of the bush. I want to point out that the poly count of this base mesh is allowed to be high because we're only going to use it for the particle system and we're not going to export it. When creating this mesh, try to keep evenly sized, evenly dispersed faces around the mesh. The particle system is going to allocate leaves around the faces of the mesh. And so we want to avoid areas where we might be able to see through the bush because there are too few leaves, because the faces were too large or too spread out. I think that I have found a nice way to achieve this. Start by adding a cube and scale it twice. S2, enter. Apply the transform. Next, add a subdivision surface and cut it 4 times. Apply that. Adding an icosphere was an equally good choice, as long as you don't use a UV sphere. Notice how the normals congregate at the top and the bottom of the UV sphere. This is a horrible choice. The shape of the bush is your artistic preference, but for now I would encourage you to just follow along. Scale the sphere along the Z by 0.5. Scale the sphere along the X by 0.75, and then apply the transforms. Cool, well, this is the fun part. Let's set up the particle system. Over here on the Particles tab, click the plus sign and assign a unique name to this particle system. This way each bush can have a unique set of settings, or we can share settings across multiple bushes. Choose Hair and check Advanced so that we can modify the rotation. Now the following settings are what I'm going to use, but these will depend on the leaf that you drew. For the number of planes or instances, I'm using 300. For the rotation, choose the normal axis, and I like to assign the randomize to 0.3. For the randomized phase, I chose 1. Under render, instead of a path, choose an object, and then use the picker to choose our leaf plane. I have a couple options here, so I'll just choose this one. For the scale, I like 0.3 and disable show emitter. This is so that when we apply the particle system, we won't include the base mesh in it. So at this point, we're ready to apply the particle system. There's an important step that I don't want you to miss, and so I want to show you something. So first, with the bush selected, just click Make Instances Real. Here's the important step. It just generated a bunch of leaves, and these leaves are actually linked to the original leaf that we picked in the particle system. Notice how the original leaf, its mesh is called Scene 9890. And if I expand one of these, all of them are linked to the same mesh. That's why first we want to click on Object, Relations, Make Single User, Object and Data. If we didn't do that, then now when we object join the leaves together, I guess after control clicking 1 to mark it as active, object join, then we would have actually joined them all into this original mesh and broken our original plane with the leaf on it. Awesome. So at this point, we could just export this FBX to Unity, but there's one last step that I want to do. So what I want to do is I want to adjust the normals of the leaves so that they all point outward like in a sphere. And I want to adjust the normals of each leaf so that it points in a similar direction to its neighbors. I've jumped over into Unity real quick just to show you the difference. Over here on the left is what the bush looks like right now if we just export it as is. And over on the right is what it looks like after we adjust the normals, which is the step that we're going to do in a moment. You can see on the right that the colors just blend together a little bit more nicely, and we don't get these harsh top sides and bottom sides. Okay, let's go back to Blender. Awesome, so we're back in Blender and we're ready to fix the normals. First, let's hide our emitter and rename this current object. We can call it Bush Final. In order to fix the normals, we need a second object. Let me hide the bush for a moment and show you what this object looks like. It can be a sphere. In my case, I made it an oval with the exact same shape as the emitter. In fact, I took the emitter, duplicated it, got rid of the particle system, and then just scaled it up until it was larger than the bush. Then I applied the transform. So now, to adjust the normals, click on the bush, go to the modifiers and add one called Data Transfer. Use the picker and choose the sphere or the oval. Choose face corner data, custom normals, nearest corner of nearest face. Apply the modifier to the bush and hide the sphere. And don't forget to apply the transform on the bush. All transforms. There's one important step. Make sure the origin is in the center of the bush. The location of the origin will be important later when we create the color gradient and the wind swaying effect. So make sure it's in the center. So now we're ready to export this bush to Unity. Go to File, Export, FBX, give it a name like Bush Final. Check all visible objects, Mesh, FBX All, and Apply Transform. Cool. So we're almost ready to start building out the shader. We just need to do a little bit of setup first. Here's the FBX I just exported. We need to assign a new material to it. First, right-click and create a new URP lit shader graph. Let's call it Demo Foliage Shader Graph. Once that's done compiling, we're going to right-click on the shader graph and click Create Material, and maybe call it Demo Foliage Material. Because we right-clicked on the shader when we created the material, the shader is automatically assigned. On our Bush FBX, let's drag and drop the new material and click Apply. Let's drag our FBX into the scene and see what it looks like. As expected, we don't see the leaves, we only see the planes. This is because we have no texture assigned and no alpha clipping enabled. If I click on our new material and look at the right in the inspector, I'll see that there are no options. We cannot configure anything on the material. That's because we haven't added it to the shader yet. So let's start by opening up the shader and let's get started. Cool. So with our shader open, there are some initial settings that we want to set. For the workflow mode, let's choose specular. For the render face, let's choose both because we want to render both sides of the leaves. Let's enable alpha clipping so that we can get rid of the transparent parts of the leaf texture. And we can leave cast and receive shadows enabled for now. Sorry, I misspoke. Let's disable cast shadows. There's another step of setup that I want to do. As you can see, the final shader has a ton of fields. So let's start by creating a bunch of categories. The first category we'll need is one to hold our main texture. And we can go ahead and create that texture now. Some of the other categories we'll need will be for the details texture, the emissive texture, the color gradient, adjusting the normals direction, fields pertaining to the wind blowing, and finally just some general settings. And on that topic, let's go ahead and expose the smoothness slider. So let's create a float called smoothness. Let's click on it, create a slider between 0 and 1, and default it to 0. Let's hook it up to the smoothness socket. All right, cool. So I think the obvious first step is just to hook up the main texture. Let's press space and add a sample texture 2D. Let's hook up the main texture T2 to the texture T2 socket and hook up the RGBA4 to the base color. Finally, let's hook up the alpha channel to the alpha here. Save, and let's return to Unity. Now in our scene view, if we have our material selected, we can now drag and drop one of our leaf textures. Great. It has no color, but we can see that the alpha clipping is working. Even though that long term we want to have a color gradient, I think for now, let's, as a temporary step, let's just have a color. I'm going to add a color node, and I'm not going to bother exposing this in the inspector because we're going to delete it. The way we add a color to a texture is we multiply it this, and then hook that up to the base color. For the color, I'm just going to choose a green color, and I'm going to save and just make sure it works. After it compiles, yeah, it's green. It looks nice. The reason I called that out is because in a moment, this color node is going to be replaced with a huge mess of nodes, which are going to form our color gradient. But in the end, it's still going to get multiplied by the base texture and then passed to the base color node. So to create the color gradient, we're going to need several new fields. And I thought I'd just start by showing you what they do. Basically, we're going to select a top color and a bottom color, pink and blue. And we're going to be able to adjust the midpoint and the fall off. You'll notice that these are both sliders between 0 and 1. Cool, so let's add those fields now. Let's start by adding the color for the gradient color top and the gradient color bottom. Let's add a float for the gradient midpoint. And remember that that is a slider between 0 and 1. And usually it's going to be at 0.5, right in the middle. And finally, let's add another float for the gradient fall off. Remember, that's how well it blends between the two colors, or if it's a hard line. Again, slider 0 to 1. And I like a value of 0.2 usually, so we'll default it to that. I apologize. There's an additional step that we should have done during setup. For this specular color, let's drop it down to black. All right, so I went ahead and built the color gradient stuff off screen. I think it would be a better use of time to just explain a working solution rather than piecing it together. But before I can get into the color gradient section, there's a little bit of math that we need to understand. If we look at the bush and we look at the color gradient, we can see that it works no matter how we rotate the object or where we move it in world space. That's an important concept because we're going to use absolute world positioning for this, and yet it seems independent. So if you've seen my rock video, then you've already seen this diagram and you've heard me explain this once. I'm going to try to explain it a little bit more quickly than I did in the rock video though. So the world center has a height of 0 because it's the world center. And let's say we've got some sort of rock or bush somewhere in the scene, like kind of floating up in the air, or maybe it's on a ledge. If we looked at the transform of that rock or bush, the transform might say that its Y position is 45 because its origin were 45 units from the world center, like above the world center. If we wanted the height of the mesh, we could take the topmost vertice and subtract it from the bottommost vertice of that rock. And if you were to rotate that rock or bush around, then you would see that there was a new topmost vertice or a new bottommost vertice, and then the height would change too. Because like rocks are like oblong shaped or maybe longer than they are tall. So the last thing is that if you looked at each particular vertice on that rock or bush and you subtracted like its Y position from the world origin minus the bottommost vertice, that would tell you how many units above the bottommost vertice that vertex is. So if the bottommost vertice is at 40 from the world center, and if this vertice is at 42 from the world center, then it is 2 units above the bottommost vertice. If we were to subtract those two numbers and get that 2, and then divide that by the total height of the mesh, then that would give us sort of the percentage from the bottom of the mesh that that particular vertice resides. So in this particular case, if we look at the math at the top, 42 minus the minimum, and then divided by the total height would give us a 0.2, suggesting that this vertice is roughly 20% of the way from the bottom of the vertice toward the top of the, from the bottom of the mesh toward the top of the mesh. I'm sorry. So to access this minimum vertice, the Y position, and the maximum vertice, the Y position, we can actually access this world bounds object. You can do that in C# as well by just like getting the renderer component. But over in shader graph, we can just use this object node and access the world bounds min and the world bounds max. And then it has, if we split and take the y, that'll give us the world bounds min.y to world bounds max.y. Likewise, we can get the bounds.size and then get its y, and that's the height. And then so if we looked at the position node, this is the absolute world position for each vertice on the mesh. Take its y, subtract the minimum, and then divide by the height. And that'll give us a value between 0 and 1 for each vertice on the mesh. So this 0 to 1 value for each vertice is a really useful metric to have, and we're going to use it in two different places. Let's return to our example for a moment. Right now, the top edge and the bottom edge of the smooth step are overlapping and right at the center. That's why we have this hard line. As I increase the fall off just a little bit, one edge moves up and one edge moves down, and we blur in between the two edges, or we blend. As I continue to do that, the top edge moves up, the bottom edge moves down. Any value or any percent from the bottom that is outside of these two thresholds will just be a solid color. So if the midpoint were at 0.5 and we went up 20% or down 20%, then the topmost parts would be green and the bottommost parts would be blue, and only the values between the two edges would be blended. So if we calculated each vertice on this mesh and ran it through that math from earlier, we could determine that, say, this vertex right here is roughly at 40% or 0.4 from the bottom, and therefore it actually resides within the two edges, and therefore it's part of the blend. Or maybe we look at the vertice down here and it's only 0.1 from the bottom, and it is outside the threshold, so it's a solid blue. That's why we'd want that like 0 to 1 value for each vertice, so that we can know where it resides within the two edges. Cool, so we're almost done with this. So we plug that 0 to 1 value in for each vertice, and we define our two edges like this. We take the midpoint minus the fall off, so 0.5 minus 0.2, or 0.5 plus 0.2, and that's how we define where the two edges are. Afterward, we could plug the smooth step into the lerp, but we just want to make sure that it produces a value between 0 and 1, because a lerp's T expects a value between 0 and 1. So saturate is just a clamp where we preset the min and max to 0 and 1. You could just use a clamp. But we're going to lerp between two collars. If this produces a 0, we'll get the bottom collar, A. If it produces a 1, we'll get the top collar, B. And at the end, we just multiply it by the sample texture like we did in the beginning when we just used the temporary collar, plug that into the base collar, and we've got a gradient. So I just want to take a breather for a moment and show off what we've done so far. So we can adjust where the midpoint is and increase the fall off. And if we choose two slightly nicer colors, yeah, I'd say we have a halfway decent bush here. And again, the gradient works regardless of how you rotate it, which I think is pretty cool. But we're not done yet. All right, so there's an additional step we can take to take this stylized look farther. In the beginning, we copied the normals from that sphere onto our leaves, and that made it look a little bit better and smoothed out the colors. It made the shadows less harsh, and it gave us less distinction between the leaves. But we can actually take that farther. We're going to add a slider that allows us to fake the normal direction. Basically, as we increase this slider, each of the leaves, the direction of its normals is going to start to rotate and point toward the sky. Let me just show you what that looks like. So some value, I think, between 0.5 and 0.9 is usually kind of like the best look. Here are some examples over here of like the final product. And all of these, I think, have a normal up of 1. It depends on the viewing direction how the colors blend. And over here are a couple of more examples, and again, all of these have a normal up of like roughly 0.7, 0.5, 1, around there. And so to achieve this effect, we only need about 6 nodes and 1 new field. Under the normals direction category, I added a normal upblend float slider between 0 and 1, and I defaulted it to 0. So we'll opt into using it if we want to. The graph starts with a vector 3 that points to the sky. It points to the sky because it has a y of 1 and 0 on everything else. It's the up vector. But to actually make it point to the sky, we need to interpret it in world space. Then we'll transform it to object space when we add it back onto or blend it back into the original normal vector in object space. So this is the direction that the normal is currently facing, and we're going to blend into or lerp into like the sky direction by this amount. So 40%, 60% from what it was toward the sky. At the end, I'm just going to transform it back into tangent space and choose a type of normal. Don't forget to choose type normal here. And I just plug that into the fragment normal. And again, I just want to take a breather and show what this does. So if I drop it back down to 0, this is what it was before we added that section of the shader. And again, this works even if you rotate it. Let's increase the value to maybe half. Again, rotate it. I think it just makes the leaves blend together a little bit more smoothly, and it gets rid of those harsh like back faces or bottom faces. So I think this is a nice addition, and it helps to achieve that stylized look that we're going for. The next section that we're going to work on is being able to add like a details texture that overlays on top of the leaves. So as usual, I just want to show you what it does first. We're going to add a field to be able to assign a details texture and to be able to adjust its tiling or its scale. We'll be able to use the slider to turn on or off and adjust the intensity of the texture. And finally, we'll be able to adjust just the color of the texture. So this is typically only going to work if you have a texture like that's white or white on transparent. If you have a colored texture, then you would just want to assign this to white. So to begin with, let's just add a few fields. To start with, I forgot for the main texture that we should check use tiling and offset. That'll enable that tiling and offset fields in the inspector for the main texture. The first field we want to add is a new texture 2D called Details Texture. Let's drag it to the Details Texture category, click on the texture, and again, enable tiling and offset. Next, let's add a color for the Details Texture. Details Texture Color. And again, we'll only use this if the texture itself is white. And finally, let's add a new float for details amount. Or I guess we could call it maybe intensity. It's a slider between 0 and 1, and we'll leave it off by default. Adding one texture on top of another texture is just a simple matter of lerping from the old texture to the new texture by some amount. Let's add a lerp node. Currently, the quote old texture is the texture combined with the gradient. So we'll drag the multiply node into the A socket. The lerp will go into the base color, and we'll keep using the alpha from the original texture of the leaves so that we won't draw the dots onto empty space or something like that. We only draw like the dots or the texture onto the parts that actually have a leaf. So the remaining section is just to hook up the new texture that we're going to lerp to, and then by what amount. As I'm sure you've come to expect by now, I built this off screen and I'm just going to explain it. First, we drag in our details texture and we plug it into a sample texture 2D just like we did with the main texture. And just like we did with the main texture, to give it a color, we multiply it with a color. The result of this, the texture plus the color, that's our B. That's what we're going to lerp from the old texture to the new texture, the old texture plus gradient to the new texture plus color. The amount that we're going to lerp, we're going to plug in this saturate node here. Basically, we take the alpha from the new texture and we just multiply it by some intensity and then saturate it. Saturate again is just clamp from 0 to 1 because a lerp's T expects a value from 0 to 1. So just in case I didn't explain that very well, I think of this as having two different masks. When we're trying to decide if we're going to draw something, first we look at the alpha of the main texture. There has to actually be a white leaf in the texture there for us to draw anything at all. Then the second mask is the alpha of the details texture. First, the texture has to actually have something there, no transparent background, like maybe a white dot or something, before we might want to draw anything. And then even then, there's, I guess, a third mask where that's the details slider, where you have to assign a value greater than 0. So I guess there are 3 masks that determine whether or not we draw anything onto the plane. I should probably stop talking about this. But if we look at the lerp's T value, to begin with, the details texture needs to have something there. Otherwise, the alpha is 0. 0 times anything is 0. Saturate will give us a 0. 0 into the T, which means we just use the A socket. And if the details texture has anything drawn there, maybe a white dot or something, the alpha value will be some amount greater than 0, hopefully a 1. We'll multiply that by the slider. If that's a 0, 0 times anything, 0. But if it's not a 0, then 1 times something. That'll give us some value between 0.1 and 1. And then that will blend into the new texture like by 0.1 or by some amount. Again, I hope that was clear. Because we're going to do this exact same thing again with the emission texture. Cool. So now we can add some sparkly lights to our leaves for some reason, or maybe some, let's see, some sickly red dots to tell predators not to touch this plant. I don't know. But now we have a details texture that we can overlay. Cool. So for our next magic trick, we're going to add an emissive texture. I don't have a great example of what this does. I guess I should have drawn something, but basically we can choose a texture. We can choose a color. This time it's going to be an HDR color with an intensity. And then we'll have this slider where we can turn it on or off just like the details. I chose a texture that looks kind of like maybe water. And if I turn it on, you can see it creates like little, I don't know, water splashes or something. The further up you go, obviously, it just kind of gets white because it's emissive. So this would ignore any lights around it. So it theoretically like glows in the dark or something. So I chose blue, but we could choose any color. And then likewise, you could draw like a cool emissive texture onto your leaves and use that instead. So something that maps perfectly to your leaf UV or to your leaf texture, I guess. And you could have parts of the leaves that glow like just like the center pieces or the little lines that go out, maybe just the edges. I'm not really sure, but that's what we're going to add is an emissive texture with an intensity and a color that's HDR with an intensity as well. All right, so the emissive texture section is very similar to details. As you can see, there's just like this little bit right here. But basically we start with our emissive texture, tiling and offset enabled. We create an emissive intensity float slider. I did 0 to 15. I've never gotten to 15. Normally I cut off about 5 or 6, but 0 to 15. And finally, and make sure you get this one, the emissive color, set it to HDR. When you set a color to HDR, it adds this intensity slider. We might not really need that since we have this emissive intensity, but just do it. Cool, so let's cover this section. We just start by plugging the texture into the sample texture 2D. No surprises there. And this section right here, I struggle to put this in words, so bear with me. Basically, we're going to take the color and we're going to mask it with the alpha. We need to use the alpha somewhere because we want to be able to use images with a transparent background. So we need a way to mask out the parts or produce a 0 value for the parts, for the pixels that are transparent. We only want to show the parts that have, a white or a color or something there. And so we need to use the alpha somewhere, and this is how we do it. We multiply the alpha by the color, And so no matter what the color is, if the alpha is 0, if the pixel is transparent, well, in that case, we're going to produce a 0 and we'll draw nothing. So let me just, I guess, show an example. This texture right here has a transparent background and has, white here and some colors there. And the background, again, is transparent. And so for each pixel that is transparent, the alpha would be 0. We would multiply it by the color, which doesn't matter what it is, will give us a 0 value, and then we won't produce. The multiply will produce a value of 0. Like I said, I don't know how to put it in words. But anyways, we're going to mask the color by the alpha, and then we just simply, if we get a value, greater than 0, we're going to multiply that by the intensity slider, multiply that by the color. Multiplying by the color is the same as we've been doing, details texture times color, or main texture times color gradient, and then multiply by the emissive color, which was HDR. We don't lerp this time because we're just going to plug it right into the emission node. So let me show you a couple of examples of what we can do with this. So this first example, this Sparkle Atlas, it's not even mine. I don't even know what asset pack I got it from. Apparently ARPG effects. But I was just looking for an example to use for this. And basically I added little like Christmas lights or something. And again, if you just increase the intensity, they'll glow more in the dark. So even though this is in the shadow right now, it doesn't care because it's an emission. It's plugged into the emission node. And then the first example I think I gave was, oh dear, dirt, water. Yeah, the first example I think I gave was just, I assigned the color to blue and used this weird thing to create like water splotches, I guess. Water splashes? I don't know. Yeah, I didn't have a really good use case for this. Really just for the video, I just wanted to show how you could do this. I imagine maybe in some sort of fantasy forest scene or something, the leaves glow at night, like in Ajara or something from World of Warcraft. I don't know. Maybe Ashenvale. Like you have like a purple plant with things that glow. Actually, I have an example here. This is maybe a little bit more advanced, but in the Blender section, I actually emitted 2 particles using a collection rather than an object. So I have this like fern and I have these leaves. The leaves have the details, you see the dots, and the fern has this emission, and each of them is a different color. So, and then this actually glows. This might not be a great example after all, but I don't know. I think this belongs in like a fantasy forest or maybe in the trash. It might go there too. So yeah, but this is how we can add an emission texture. And again, I don't know the use case for this, to be quite honest. All right. So for the next section, we're going to add the wind blowing effect. I started off by duplicating the same bush multiple times because there's a feature that I want to demonstrate. But first, let's look at some of these values in the inspector. We're going to expose a field called bend strength. And this is going to allow us to adjust kind of how far the leaves actually move left and right, like how far they bend. So if I set this to a value of like 4, maybe 3. All right. I'm hoping that I can catch a good example of this, but the way it's going to work is the wind is going to blow from the right to the left, hopefully, and it should collide with the bushes on the right first, and only after passing through that bush will it reach these center bushes and then the left bushes. Let's see if we can catch an example. So, right here. So it should come through and pass through. Yep, there's one. Right here, this is a good one. That was a really good depiction. Awesome. So yeah, so the wind should hit the rightmost bushes first and then travel along the x-axis and kind of appear to be passing through the bushes. This would be opposed to a bush where that just kind of jitters kind of on its own and has no regard for its absolute world position. Cool. So next is the wind speed frequency. This is how fast or how often the bushes are going to move left and right. If I crank this up, you'll see what I mean. Right here. It doesn't make any sense, but you can see the effect that this has. Set it back down to 4. Maybe there's a big storm going on right here. Ooh, that was a really good one right there. Cool. All right, and for the last value that we want to change, let me pick one of these bushes up. And then let me crank up the movement amount. And let me turn this off. All right. So for this particular bush, you can see the top vertices move, the bottom vertices move. See? And what we can do here is we can use this slider to kind of lock or stop some section at the bottom from moving at all. So imagine like this bush is like rooted into the ground. Then the roots shouldn't move. So maybe the bottom 20% of the bush should not blow in the wind. So if we just increase this to like 20%, you'll see this one just stop moving completely. And if I take it way up, look, only the top parts move. Cool. And those are the three values we're going to expose in the inspector. So next, let's move on to the actual graph. Guess what? I built the graph off screen and I'm just going to explain it. So to start with, up until now, we've been adjusting the color of the bush with gradients and details and emissive and stuff. And we've been plugging the result into the base color and I guess the emission. Now we want to plug something into the vertex position. And I just want to call your attention, whatever we plug into the vertex position, it should be in object space. Just keep that in mind. Cool. So this one's a little messy, and for that reason, I put it into a subgraph. We'll look at the subgraph in a moment, but I think what's important is just to kind of recognize what goes in and what comes out of the subgraph and just kind of treat it like a black box. First, we need that wind speed, the frequency, how fast it moves left and right. We need the bend strength, plug in the bend strength. That's how far it bends in the wind. And then the wind stop percent, again, don't move the bottom 20%. Then we have this vertex Y position. So think back. Earlier, I mentioned that math that we did with that crude diagram, that 0 to 1 value for each vertice, I said we would use that twice. We would use it with the color gradient, and we would use it with this Y stop percent. It should actually make sense to you conceptually why we would want this. If we want the bottom 20% to not move, and this produces a value between 0 and 1 for every vertice, then we want those vertices which have a value of 0, 0.05, 0.1, 0.2. We want those vertices which have those values like below some threshold, like 0.2. When we plug it into this black box, we expect those vertices will not move. And then the ones that are above it will progressively move more and more until they reach the top. So that's why we would want it. We haven't seen, how we're going to do it, but that's kind of the concept. Next, you'll notice as far as the outputs go, we've got a merged object space and a delta only. I'm going to ask you to just ignore this delta only. I was going to demonstrate something and then it didn't quite work out. But what it is the merge object space is the one we want. What that is this is the new position for each vertice. So for each vertice that comes in, this is the new position that it should be at, the new vertex top position. The delta only was actually just how much it should move by, but it wasn't the new world position or object position. So I was going to show something and I didn't. All right, take a breath. Here we go. So here is the full graph. I'm going to explain the graph probably 2 times to kind of get in. I'm going to start at a high level and then I'm going to move down. So let's start from the right. All right, I'm going to cut all this stuff off. No matter what we do on the left side, no matter what computation we perform, the final result needs to be in object space, because remember, that's what that needs. So whatever we do on the left, transform world to object. Let's move left just a teensy bit. All right. Now, whatever we do on the left is going to arrive at this combine node. This combine node is going to produce like a vector, the vector 3. Looks like we're using it as a vector 3. It's going to produce a vector 3, and this is the amount to move the vertice by. So again, we just forget how we got here or what we did or how we computed it. Just this is how much we're going to move the vertice by. You may notice that I've put a 0 here for the y, x, y, z. There's a 0 for the y because we don't want to move any of the vertices up and down. Maybe if you were trying to fold down a flower or a piece of grass or something, that might make sense where you would like move a vertice up and down. But for our purposes, we're going to move it on the x-axis and the z-axis, laterally. If this is how much to move by, and we add it back to its current world space position, then the output from this node must be the new position. This is where it's going to be afterward. So this is, move it by half a unit, add half a unit back to its current position. This is where it's going to be now. Cool. All right, so let's zoom out. Let's come over here and take a look. This section here helps us compute the main logic for moving or swaying with the wind. And this section above is how we make the wind blow through the multiple bushes in a cascading effect based on their absolute world position. So we take the absolute world position of each vertex, we rip out the x and the z, we don't care about the y, and we create a new vector 2 because we plan on plugging the vector 2 into the UV socket. Most of the time when you see how people make bushes move in the wind, you'll see them multiply a progressive time amount by some value that we can control, like the speed. And then a lot of times they'll plug that into the tiling and offset, and then into the simple noise. That's basically all we're doing here. It's just that we're changing the UV to be its position in world space so that certain bushes will be hit first or later, and it'll happen pretty much along the x-axis. You'll notice here we put a 0 for the y. Let me show you simple noise real quick. I'm just going to unplug that. This is what a simple noise looks like. And if I were to plug this in, you'd see it moves from right to left. The thing is like this section is black and this section is white, and it flickers back and forth between black and white so quickly that if I were to plug this in and save it, let's just do it, actually. Just do it. Yeah, this is what it does. So anyways, the change in value is way too harsh, and we need something significantly more subtle. And we do that just by bringing the scale down to 1. It's probably hard to see, but this shade of gray, it is changing. It's just changing so subtly that you can't really probably see it in this compressed YouTube video, but it is changing a little bit, and that's the amount that it should change by. That flickering back and forth, those values were just too large when we were moving, vertices by like a fraction of a world unit. So that makes sense. Anyways, so what comes out of this like whole left section? This kind of gives us our direction, and this gives us a scalar value. The output of this is a scalar value. If we had to use sine, because you see a lot of people will use sine when they do this, that'll give you like a very small like percentage or a small number, because this is just a scalar value that we hope to get out of this. It's not the actual amount to move by. It's just like move a lot or move a little. That's what we're trying to achieve. The actual units that we're going to move by are going to come when we multiply this by the bend strength. That's like how deep we should move it. But at this point, it's just like a move a lot or move a little, a scalar value, very small value. All right, cool. So this left side gives us some sort of a scalar value. And I already said that by multiplying the scalar value by the bend strength, that tells you how much to actually move by. But this subtract 0.5 is probably confusing you. Let me show you what happens if we don't have that. So I'm just circumventing it here. It's a little difficult to see, but if this is where the origin is in the bush, the transform, this gizmo, is shown at the origin of the bush, you'll see it's kind of off center a little bit. As we move the vertices like around or on different axes, the origin is like kind of in a different place relative to the new center. Especially if I turn off the stop percent. Oh, that's it. There you go. Now you can really see it. You can see the outline where it used to be, where it originally is. And then, but visually, it's off center clearly. If I just plug back in that subtract node, I'm going to do this off screen so you can watch it. Boink. There. It recenters itself. All we're doing there is just kind of visually trying to recenter the visual appearance of the bush now that the vertices are moving. But this is just a nice to have, and we don't have to have this. I just like kind of recentering it a little bit. But that's why we have that. All right, we're almost done. So let's recap. This left section gives us a scalar value, how much to move by, a lot or little. After multiplying it by the bin strength, we have a precise amount that we want to move by. And after subtracting half, we've recentered the bush around like its new origin. So the last step here really is to apply the vertical stop percent. Remember, what we want to accomplish or achieve here is to be able to use that slider and say, do not move the vertices below, like at the bottom 20%. And for the vertices between 20% and the top, progressively move them as we go up. So that's what this does. It's just a mask. We plug in our wind stop percent, which is like 0.2, 0.3. And we plug in the vertex Y position. Remember the crude diagram, 0 to 1 value for every vertice, 0 at the bottom, 1 at the top. So we multiply that by the amount that we want to move by. And okay, I'm going to be honest with you. This divide node here is a bit of a hack. Really, I've only computed a move amount along the x-axis. But what I noticed was that all of the bushes really only did move along the x-axis. They never really moved forward and back at all. What I could have done was maybe duplicate this or do something like this again for the forward and back axis, for the z-axis, I'm sorry. I really didn't feel like it. And so all I did was just divide this number by 2 so it moves a little less on the other axis. When I plug in this multiply node to both sockets, the X and the Z, I noticed the bushes always move at it like a diagonal, and I didn't care for that. So I just divided it by 2 so that it moves a little bit less on that axis, but really this is only logically set up to move along the X. So I cheated a bit. All right, so let me just show you the whole graph again. Kind of hold it still here for a minute in case you're trying to pause it and build this. While you're doing that, I'm going to click on the output node and just show you that both outputs are vector 3. Then I'll click on the different fields here and just show you what they look like. They're just floats. I didn't do anything to them. Cool. All right, fellers, we done it. Let's see what we've cooked up here. Oh, wait. Don't go forgetting about poor old wind sub graph. Let's take a gander. Just dandy. All right, let's mosey on back to the shrubbery shader. Yep. Well, that ought to be enough time for you to etch that down on your slate. Well, all right then. I think we did a pretty good job here. So I'm going to close out this video just by showing some of the different styles I came up with our new shader. And I'd also like to say that this is only my second YouTube video. So if you found any part of this helpful, or if you think there's something I can improve in the next video, then run, don't walk, to the comment section to let me know. And hey, I'm really glad you stopped by. I hope you visit again soon, and until then, keep making games.